As we move on to Chapter 11, Chapter 11 is all about radical expressions. What that means, or rational expressions, what that means, guys, is that you're going to have, rational means it's going to be a fraction, okay? And expression, we're going to have like x's and y's in it, okay? And you're going to learn how to reduce and simplify those. Here are the main steps, okay? Main step is you want to reduce or factor if possible. That's step 1. Factor if it's at all possible. And that came from Chapter 8. So you might need to, if you don't remember how to factor, you might need to go back to Chapter 8 and revisit how to factor. Number 2, you are going to cancel identical monomials or identical binomials. Something you have to be able to also understand is what we call excluded values. Excluded values are values that would make your problem impossible. Or maybe better, undefined. Now what do I mean by that? You have to make sure that you set the denominator equal to 0, because you cannot divide by 0. So what we're going to do is we're going to find out what would make it impossible or undefined. I want to just show you an example. Pretend you had 2 over x minus 4, okay? In this particular problem, x could not equal positive 4 because it would make your denominator 0. All right, another, maybe a harder one. Pretend you had 2 over 2x plus 3. What would make that impossible? This would be impossible if 2x plus 3 was 0, right? So we're saying 2x plus 3 is not allowed to be 0. Therefore, if you solve this out, you get 2x can't be negative 3. Divide, you get x can't be negative 3 over 2. These are what you call excluded values. Let's go on, excuse me, to problem 1. Problem 1, what is the simplified form of the following? State any excluded values. Alright, what we need to do is we need to factor if we can. So step 1, I notice that the top doesn't factor, but I do hope on the bottom that you see that it does factor. At this point in time, we have to state our excluded values. So this step was factor. This step will be our excluded values. Remember that the denominator, 5 times x minus 1, cannot equal 0. You divide both sides by 5 and you get x minus 1 cannot equal 0. You just divide by, the 5 kind of falls off. You add 1 and you say x cannot be a positive 1. Now what we're going to do in step 3 is where we reduce. And that comes from step 1. Okay? Do you notice that the x minus 1s are identical binomials? Therefore they cancel out and you get a 1 over 5 as your final answer. Because the binomial of x minus 1 is the exact same as the bottom. Now when you reduce in the numerator, please remember it doesn't just turn into a 0. It reduces to a 1. Let's try this again in the got it. Take a look at part A. Do you notice that nothing factors? So what I'm going to say is that 7a cubed cannot, I'm going to go straight to my excluded values. My denominator cannot be 0. Well, what's the only value of a that would make this 0? A would have to be 0. We're just going to say a is not allowed to be 0. That's how you solve that. A cannot be 0. That's what I'm going to call an excluded value. Now let's move on and simplify this thing. 21 over 7 becomes 3. A squared over a cubed becomes a. That's it. You reduce. 21 over 7 is 3. A squared over a cubed. I would ask you guys, I'd say, where the party at? And you said it's at the bottom. There's 1 extra. Let's take a look at part B. Part B does factor. The bottom factors to 4 times d plus 2. You have a GCF. I'm going to take a moment here. I'm going to state my excluded values. Now the 4 is really not important, alright? The only thing that's really important are the things with variables. So I'm going to say d plus 2 is not allowed to be 0. D is not allowed to be negative 2. That's an excluded value. Now that we've stated them, we can move on. Do you see that 18 and 4 cancel to 9 over 2? Because 2 goes into 18 and 2 goes into 4. The only thing we need to bring down is the D plus 2 and the D squared. Some students might think that D squared and D cancel, but you should notice that what I'm underlining here, that's a binomial, that's a monomial. You cannot reduce binomials and monomials. They're completely separate from each other. This is your final answer. Part C. The top doesn't factor, so I'll just bring it down. The bottom has a GCF of 3. I get 2n minus 3. I'm going to take a moment here and I'm going to state my excluded values. Notice I do that after I factor. The 3 is really not important. It's the denominator of 2n minus 3 that's not allowed to be 0. So I'll add 3, I'll say 2n is not allowed to be 3, and then I'll divide by 2, and I'll say n is not allowed to be 3/2. Once I state my excluded values, I can go ahead and cancel the two binomials that are identical to each other, because they're both binomials. The top leaves you with nothing, which is a 1 when it reduces, over a 3. And that's your final answer. Part D. I'm going to look at the top. In the top, there's got to be something that pulls out. I'm cheating, I'm going to your book. What goes into 26 and 91? Possibly 13. Let me take a look. I know 13 goes into 26. We got to see if 13 goes into 91. Yes, it does. We can pull out a 13 and a C. And that comes out of the top. The bottom, I hope you know, the bottom does not factor. Okay? If I pull a 13C out of this, I get 2C squared. And if I pull a 13C out of 91, I get plus 7. Now this would be where we take a break and we would state our excluded values. I will show you the excluded values on this one, although I do believe that this is asking a little much of you. It's still pretty important that you realize how to find your excluded values when it's a little more difficult. Alright. You would say 2c squared plus 7 cannot equal 0. And then you would say 2c squared is not allowed to be negative 7. And then you would divide by 2 and you'd say c squared is not allowed to be negative 7 over 2. And then you'd have to take the square root. Because this is negative, you cannot take the square root. So this means there are no excluded values. In Algebra 2, you'd learn that some imaginary numbers are excluded, but we're not going to go there right now. Alright, let me go over this one more time. Because you cannot take the square root of a negative, you would say there are no excluded values. Then you would move on, cancel the binomials that match, and the only thing you'd have left in the numerator is a 13c. The only thing left you'd have in the denominator is a 1, so we just keep it at 13c. Problem number 2. Simplifying something that has a trinomial. Well, we're going to follow my steps just like we did before. Step 1, factor. The top has a GCF of 3. So I do 3 times x minus 2. The bottom doesn't have a GCF, but it does factor down to 2 parentheses. I will suggest that you pause the video, figure out what it is, and then check your answer. The answer is x plus 3, x minus 2. Now if you let me do that for you, you're not going to have any clue how to factor. So go back, make sure you know how to factor, because if you don't, you're really going to bomb this section. Alright, let's go ahead and see let's do our excluded values next. When you do your excluded values, you take the items in the denominator and you say that they're not allowed to be 0. So look how I have 2 items in the denominator. I'm going to set both of those items equal to 0, and I've solved. The first one, x is not allowed to be negative 3. The next one, x is not allowed to be 2. These are your excluded values. Now that I've done that, I can move on and I can reduce. I will go back up to step 1. Do you see the binomials of x minus 2? They cancel. Some students may try to cancel 3 and 3, but this is a monomial. This is a binomial. So what's left on the top? A 3. What's left on the bottom? X plus 3. That's it. Move on to the got it. And we have a few more that we need to practice. And we'll just divide it up into 4 sections as we move along on the paper. Part A, let's do that one first. Factor. In the numerator, you pull out a 2. GCF. In the denominator, there's nothing to pull out. So I do x and x. Now you figure out what the back 2 numbers are. Please pause the video. You should get minus 4 and positive 2. At this point in time, we state our excluded values. And let's see, that was step 1, this is step 2. Our excluded values are when x minus 4 can't be 0. This comes from the denominator, remember. There we go. X minus 4 can't be 0, and x plus 2 can't be 0. So I get x is not allowed to be 4, and x is not allowed to be negative 2. These are the excluded values. Step 3 is the step where I reduce. So I go back to step 1, and I cancel what I can. I see the binomials of x minus 4 cancel, and I'm left with 2 over x plus 2. Remember, these 2's don't cancel because this one's a monomial and that one's a binomial. Alright, let's do part B now. Part B. Step 1, factor. In the top, there's no GCF, but you can break it down into a double parenthesis. Please pause the video, make sure you know how. You should get minus 1 and minus 2. Over the denominator, you pull out a GCF of 3. That one's not a double parenthesis, that one's just a GCF problem. Step 2, I find my excluded values. My excluded values, I set my denominator equal to 0. And I say it's not allowed to be 0. Notice I only did the thing that had actual variables with it. I add 1 and I say A is not allowed to be 1. There's your excluded value. Step 3 is my step where I reduce. Notice the binomials cancel each other, and you're left with A minus 2 over 3 as your final answer. Part C. Factor if you can. The top, you should notice there's a GCF of 6. So you get 6 times z plus 2. The bottom, there is no GCF, but you will get a double parenthesis. Pause the video. Make sure that you can do it on your own. You should get 2z plus 3 and z plus 2 as its factors. Step 2, state your excluded values. To get your excluded values, you set 2z plus 3, and you say that's not allowed to be 0. And you do z plus 2, and you say that's not allowed to be 0. You subtract 3, and you get 2z can't be negative 3. You divide by 2, and you get z is not allowed to be negative 3 over 2. On this side, you subtract 2, and you get z is not allowed to be negative 2. Those are your excluded values. Step 3 is where you reduce. Notice how the binomials are the same as each other. So you end up with 6 over 2z plus 3. That is your final answer, reduced. Part D. Last one. Step 1 is to factor. So I'm going to factor this. Pause the video, make sure you know how to factor. The top should become c plus 2 and c minus 3. The bottom should become c plus 2 and c plus 3. Step 2 is where you state your excluded values. And that's where you set your denominators equal to 0 and say they're not allowed to be 0. Okay, after you say that they cannot equal 0 in the denominator, you have to solve for each one of them. So in this one, c is not allowed to be negative 2. Here, c is not allowed to be negative 3. Those are your excluded values. Now step 3, move on to reduce. Notice that the binomials have to be exactly the same. So the only ones that are exactly the same are c plus 2. When you reduce, you get c minus 3 over c plus 3. And that is the reduced values.